The normal random variables are examples of continuous random variables that can take on any value, not just whole numbers. The probabilities of a normal random variable with mean mu, standard deviation sigma, are equal to the areas underneath this bell-shaped curve here. Part of this formula, you'll see the special number pi, approximately 3.14, and the special number e, approximately 2.718. Because these probabilities are hard to compute, we'll use a table of standard normal probabilities in the appendix and also in the course files in Canvas. Example 1. Duration of human pregnancy is approximately normal with mean mu equal 266 days and standard deviation sigma equal to 16 days. In symbols, we have a random variable x, and the squiggly sign is distributed. N is normal, mean 266, standard deviation 16. So n parentheses 216, comma 16. What proportion of pregnancies last less than 292 days? So we want the probability that x is less than 292. Now, in order to use the table, we have to convert this into a z-score by subtracting the mean and dividing by the standard deviation. So this is the probability of z is less than 292 minus the mean, which is 266, divided by the standard deviation, which is 16. Okay, and so then if we do that computation, that's 292 minus 266. 292 minus 266 equals 26 divided by 16. It's probability that z is less than 1.625. Now, actually, some of the exercises in WebAssign have links to technology that will take more digits and give you a more precise answer. Our table only has z-scores to the nearest hundredth. So if we round this off, its probability of z is less than 1.63. And then we want to look in row 1.6, column 3 of the table, of the z table. It's in the appendix and also in the course files. Now, the way our table is set up, they only give you positive z-scores and the upper half of the bell. So if you look that up, it's row 1.6, column 3. It gives you a probability of 0.4484, and then because this is just an upper half table, we want to add 0.5 for the lower half, so it's 0.5 plus 0.4484, and it gives a probability of 0.9484, so it's approximately 0.95. So about 95% of the pregnancies last less than 292 days. And our text, I actually have tables from several different texts, and you'll see links to those tables in WebAssign. If you use the table in the course files, or the table that's in our assigned text, OpenStack's intro to business statistics, then you'll see just the one-page Z table, and that's the way you do it. If you're using a two-page Z table, usually those are a left tail table. In that case, you don't have to add the 0.5. So sometimes for certain problems, the two-page table is easier. And for example, for this problem, it's a little easier. You don't have to add the 0.5. But for other exercises, the one-page table is easier. But anyway, I would suggest you get used to using the one-page table, because that's the one that in our text, and it's also the one in the course files. Okay, so example 1b, what proportion of pregnancies lasts more than 292 days? So it's going to be the same z-score, except we have a greater than symbol here. And what's in our table is this shaded area here that's between 0 and 1.63. What we want is the z-scores to the right of that. So it's going to be 0.5 minus the table, 0.5 minus the 0.4484, and that's 0.0516. So that's approximately 5%, rounded off 0.05, so approximately 5% of the pregnancies last more than 292 days. And just a note here, for normal random variable, for any continuous random variable, the proportion of scores that are exactly equal to a particular number is considered to be 0. Because there's an infinite number of numbers here. Between you could have 1.62999 and 1.6299999, 1.6299999. There's an infinite number of numbers, so so you can't assign a positive probability to each one of them. We only give a positive probability for intervals. So it has to be an interval here. Here we have a probability from above 1.63, so that gives an interval, or less than 1.63 gives an interval. The probability that it's exactly equal to a particular number is considered to be 0. Okay, so but we could ask what proportion of pregnancies last about 292 days, rounded to nearest whole number. So that would be the pregnancies lasting between 291.5 days and 292.5 days. So that's a probability that x is between 291.5 and 292.5, and we want to convert both of those into z-scores. So it's 291.5 minus 266. Divided by 16, less than z, less than 292.5 minus 266 divided by 16. So we convert both of those into z-scores. This is approximately, let's see, I'm going to round this off, 291.5 minus 266 equals, divided by 16 equals, we get 1.59375. Less than z, less than, and then we have 292 minus 266 equals, divided by 16 equals 1.65 625. So again, if you're using technology, you can keep all these digits, and they'll give you a more precise answer. Our table only has z-scores to 2 digits after the decimal point. So if we round these off, we get probability that z is between 1.59 and 1.66. And then we look in row 1.5, column 9. And we get 4441, and look in row 1.6, column 6, and we'll get 0.4515. So again, our table, if you're using the one-page table, they give the z-scores between 0 and the number. So the first z-score is more area than we want. We want just the z-scores between 1.59 and 1.66. So if you just use the 0.4515, that's more than what we want. What we have to subtract off is the probability of the z is between 0 and 1.59. So you want to subtract off those two z-scores. We get approximately 0.0074, which is less than 0.01. So it's less than 1% of the pregnancies last 292 days rounded to the nearest whole number. Okay. We can also use the z-table in reverse. The z-table is set up to look up z-scores. If you're given a probability and you want to find the z-score that goes with that probability, then you have to use the table in reverse. Let's see if I can find a table here. So we this question here, we want to know how long the longest 3% of pregnancies last. The longest 3% would be on the right extreme here, the right tail, and the shortest 97% would be on the left side here. And so 0.5 plus the table has to equal 0.9700. That means this portion in here has to be 0.4700. So we want to look for 0.4700 in the body of the z-table. The closest number is in is 0.46. Closest probability is 0.4699. It's in row 1.8, column 8. So the z-score is about 1.88. It's actually probably, or you could maybe guesstimate 1.881 because this 0.4699 is a little bit lower than the 4700, so maybe it's actually a little bit above 1.88, but you could use 1.88 or 1.881, and then then we want to find the x score that goes with that. So we want to solve x minus the mean, which is 266, divided by 16 equals 1.88, and solve for x. So that means that you multiply both sides by 16. Multiply both sides by 16. X minus 266 equals, and then 16 times 1.88, uh, 30.08, and then add 266 to both sides. So you get x is equal to 296.08 days. So the longest 3% of pregnancies last over 296.08 days. Okay. The shortest 3% of pregnancies last how long? So now we're at the lower extreme. We have the lowest 3%. So the bell curve is symmetric. So this is going to be the same z-score except for the sign. The bell curve, you have 0 in the middle. 1.88 would be over here somewhere. That was from the last problem. And because of the symmetry, this is the highest 3%. because of the symmetry, this is going to be the same except for the sign. The z-score of 0 is in the middle. Negative 1.88 would be the z-score for the lowest 8%, or you could use maybe guesstimate negative 1.881 would be a little bit more accurate. So it's the same process. You want to solve x minus 266 divided by 16 is equal to negative 1.88. Multiply both sides by 16. You get x minus 266 equal to negative 30.08. Add 266 to both sides, but really you're subtracting because you have opposite signs, and you get x is equal to 235.92 days. So the shortest 3% of pregnancies last less than 235.92 days. Okay. The 80th percentile. So we've had several ways of computing percentiles. We had a formula for doing that. We can also use the z-table. If it's a bell-shaped graph, we can use the z-table to find the percentiles. So the 80th percentile would be the length of pregnancy that's more than 80% of the pregnancies. So the 80th percentile would be we're looking for the shortest 80% of pregnancies, because that's what 80th percentile is more than. It's more than that short 80%. Now, if we're using a one-page z-table, only the upper half is going to be in the table. So we need to subtract 0.5 and look for 0.3000 in the body of the z-table. The closest numbers are in row 8.4, columns 0.8, columns 4 and 5. And the closest numbers 0.2995 and 0.3023. So the z-table, let me just draw the, if we go down to row 0.8 and go across to column 4, we have 0.2995, and if you go across to column 5, we have 0.3023. Okay, and so the z-score is going to be between 0.84 and 0.85. It's going to be closer to 0.84, because if you look at the last digit here is off by 5. This one's off by 23. So it's going to be closer to 0.84. I would estimate maybe about 0.842 is my estimate for the z-score. And then the next step, you want to solve x minus the mean, which is 266, divided by 16 equals 0.842. So again, we want to multiply both sides by 16. And 16 times 0.842 is 13.472. And then add 266 to both sides of the equal sign. So we get x is equal to 279.472 days. So the 80th percentile is 272.472 days. So that's 80% of the pregnancies last less than that number of days. And that concludes this presentation.